Hello, long time, my students. Today, we want to continue from where we stopped. It's been a long time we've met. Oh, this is the solution to UTME question 2015, Physics 11 to 20. Let's look at number 11. Now, number 11 says that a dynamo primarily conducts dash it always conducts mechanical to electrical energy. It's like the kanji dam that we use there. So let me check the answer. A, potential to kinetic, electrical to kinetic. C is mechanical energy into electrical energy. So that's the final answer there. So C is the answer. A dynamo, let me just quickly write it. A dynamo converts mechanical energy to electrical energy. And this C. Number 12. Number 12 says that okay, we're given a diagram here, and that diagram we can see there is they say that a particle is injected perpendicularly into an electric field. It travels along a curved path as depicted in what? In the figure above. Since this thing is moving this way, attracted to this path, and we know from here current is passing through, the electric field is passing through, so the current here is from positive to negative in this case. Now that means that we'll be having the negative charge to this point, and that will be beta in this case, and beta is more or less like electron. So the particle is electron in this case. So you can see that G is the final answer. So we have our answer to be what? Since it's attracted in that line, number 12 is what? Is electron in this case. And that's D. Let's check number 13. Number 13 says that from the whole thing here, it says that what? Okay, we have in which of the following diagram is the length of the tube equals to wavelength? So they gave us the first one, second one, third one, fourth one. Now, how do you get it? So let me give you the rundown of this. So anytime we have a tube and there is a kind of wave in it. So like this one, like this. See this one? It's like from here to here is like lambda over 4. Look at it here. If you have it like this, this is like 2 of that one. This is lambda over 2. If you now go like this and you have it like this, see that? So if you go like this, so the 3 is now like 3 you are having. So from here to here now, we give you lambda 3 lambda over 4. So look at this. The last one here, you have it this way, this, adding this, then this one goes, meet it like that, I mean like that. So we have how many now? This is quarter, another quarter air, another quarter air, another quarter air. So we have how many quarter? 1, 2, 3, 4. So that is lambda, 4 lambda over 4. So quarter. So we have a whole lambda air. So this one means the lambda. So here we have lambda over 4. We have 2 of it here. It's like you have 2 times lambda over 4, which give you lambda over 2 here. Here is like 3 times lambda over 4, which give us 3 lambda over 4. And here is 4 times lambda over 4, which give us the lambda, which is the wavelength that we said we should look for. Let's look at which one give us the answer. So that's A here. It is A. The answer here is A. A is the final answer in this case. Now let's look at number 14. Number 14 is the next thing to be solved here. Number 14 says that a calibrated potentiometer is used to measure the EMF of a cell because the internal resistance of the cell is small compared to that of no. The potential difference takes no current from the cell. Yes, that's true. The potential difference take no. At that point, we have a balance point. They call it balance point, where there's no current that is passing through the whole potentiometer. Everything is balanced. So that is potentiometer. If you don't know anything about potentiometer, you can just contact me or ask question about it in the section below, in the comment below. Just put your comment there that you want more explanation on that. I will do that. I will do just that for you. So now in this case, what we have there is that from the question, the potentiometer, no current is passing through in that case. So that is when you measure the EMF. No current is passing through. That's when they say that non-deflection at that point. So that's B as depicted in that place. Let's go to number 15. Number 15 says that which of the following is a vector? A is electric charge, no. Electric potential difference, no. Electric field, yes, that's it. Electric capacitance. Anytime you want to know, they give electric field intensity, all of them they are what? Once you hear electric field or intensity, gravitational field, intensity, magnetic field intensity, they are all what? Vector. Is that okay? So the answer in this case here, in number 15, in this case is that we have what? Electric field is a vector. Vector, that's C in that place. Now let's go to number 16. Like I said, number 16, which says that the photocell works on the principle of the photovoltaic cell, photographic plate, emission of proton by incident electron, emission of electron by incident radiation. That is the right answer. For you to have anything called photocell, the photocell works on the principle that when incident ray falls on that photocell, the incident ray will cause emission out of it. So that is what we call the photoelectricity. So in this case, the answer here is the emission of electron by the incident radiation. So now number 16, as we see there, number 16 means that what? Electron photocell is works with what? Emission of electron emission of electron by an incident radiation. That's D. Number 17. Number 17. We're told that when an atom loses or gains a charge, it becomes, that one is straightforward. It becomes an ion. An ion. That is A. Now, let's look at number 18. Number 18 says that which of the following characteristics of wave is used in the measurement of the depth of the sea? Diffraction, reflection, refraction, interference. The answer there is reflection. Number 18. Let's take number 18. From this, we have number 18. So reflection assists in the measurement of the depth of a sea. So what is used there really is reflection. When they put the machine there, that will send a signal and it will get to the depth of the seabed, then it will send it back. So that time interval we calculated, and with that we'll get the distance using the velocity of sound in the sea. So that is how it is done. Let's look at number 19. Number 19 says that which of the following are produced after a nuclear fusion process. Now this one, to explain this, we need to understand that there is nuclear reaction. And in nuclear reaction, we have two types of nuclear reaction. So the nuclear reaction we're talking about, nuclear reaction, we have two types there. Is either you say that you have nuclear fusion or nuclear fission. This one signifies fuse together, that is combine from the word fuse. Why this one means split, to split something, from the word division. Fission means division in this case. So this one, when you define this one, for nuclear fusion, just like I said, is what? It means fuse together. So nuclear fusion, from the word fusion, it means the combination of light nuclei or at times they say nucleus to form heavy nuclei and enormous energy. While the nuclear fission is splitting of a heavy nuclei to form smaller, two smaller nuclei of comparable masses. Even though energy is given, but not as enormous as that of the nuclear fusion. So let's now look at what they have for us there. So from the question, they said what are produced. We can see one heavy nuclear is produced, that is nucleus, and energy produced. So we are talking about 1 and 4. So the answer there is 1 and 4. That is, the answer here is 1 and 4. That's talking about what C. The last question there, which is 20 for today, is what? It said two similar kettles containing equal masses of boiling water are placed on a table. If the surface of one is highly polished, while and the other surface of the other is covered with soot, which of the following observation is correct? Now, usually when you see things like this, what you will see is that we're talking about radiation in this case. When you have polished surface, at times they will tell you it is black surface. Black surface. Why here is soot? It's like you use that flame coming out from candle, just use it to cover the tin, a tin like that. So that is what we call soot. So anytime you have something like this, it's like you are covering it with silver. Is like a silver surface. This one is not a good radiator because it absorbs it too much. But air is a good radiator. It radiates it easily. Don't forget, we have radiation, 3 ways by which heat is being conducted. We have conduction, convection, and radiation. So if you notice in thermos flask, we use 2 silver wall there because we want to reduce the radiation of the whole thing. So that is why we use radiator air. This one is a good radiator, and at the same time, or we call it a good emitter of heat. A good emitter of heat. This one is not a good, it's a poor radiator. It won't release the heat on time. So let's now see what they will tell us as the observation. The options there, they said the 2 kettles will cool down at the same rate. No. The polished kettle cools down more quickly by conduction. No. The kettle with soot, covered with soot, cools down more quickly because it is a good radiator of heat. That's just the answer. So in this case, it means that we have the answer here to be what? To be C. C. So that's the final answer. I believe with this, you understand this in short. So in case you have any issue, you can still contact me on my phone number or on our new Telegram 08022706148. If you are new around here on the channel, you can still join the new platform and enjoy all you want to enjoy for jam or for our egg anytime. See, then do me a favor here. Click the subscribe button so that we can increase the number of people on this platform, and that will enhance me to also do more to this platform. Then don't forget, if you like this video, press the like button and share to your friends, even to your enemies, so that they can join it. They can enjoy it the more. So I remain your maths and physics coach, Okunbo Notajudi. See you when I see you, and bye for now.